So how do we add texture? First, we load the bitmap of the texture. Again, the bitmap of the texture is nothing but an image which depicts how the scene or the object should look at every pixel. And this bitmap could be of any size, and you need to associate every pixel of the terrain with a corresponding pixel of a texture. So every time your pixel on the terrain is drawn, it is given the pixel of this texture bitmap. It could be of any size you please, but just to keep things simple, I have used the texture which is of the same size as the terrain bitmap. This just lets me have a one-to-one correspondence between the pixels, so every pixel on the terrain is mapped to a singular unique pixel on the texture. And an optimization step is that you can do this in the same loop as drawing the terrain, so we don't need extra steps to do this. Let's quickly see how this fits into our code. And I've already taken the liberty of making another file, which is essentially the same code, but I add the texture part to this. And here it is. This is the function that loads the texture given a texture bitmap, which is passed as an image object. It loads the texture and has a texture ID that associates with this particular texture. Now, in our init function, we create a new image object and we call load BMP from our image loader file, just the same way we did for the terrain. And we then call load texture on that particular image. So now we have a new texture created, and the texture ID is passed on to this texture ID variable. The difference in draw scene is the fact that we have to enable a couple of things like GL texture 2D, and we bind this texture 2D to the texture ID that we just created, and we sort of specify GL linear, and what this does is it gives us a kind of a smudged effect, if you will, instead of blocky effects at the edges of the pixels. And according to me, it just looks better. Either way, it's pretty much the same thing. In our nested for loops, we have a couple of variables, which I'll just get back to in a moment. But the main part is here, where just before specifying the vertex, we specify the corresponding coordinates in the texture bitmap, which happen to be x1, y1. And similarly, we do this for the other point, x2, y2. And how we get this x1, y1 is pretty interesting, because when we load the texture dimensions only go from 0 to 1. And so even though our original image is 255 pixels by 255 pixels, the 0th pixel corresponds to 0 and 255 corresponds to 1. So we just need to do this little mathematical jugglery here so that we normalize the current pixel in terms of what the corresponding pixel in the texture would be, and that's how we get x1, y1, x2, and y2. So let's see how our terrain looks after adding this texture. And there you go. Now the red color has been replaced by a nice texture which looks like grass and some brown patches over there. So it's beginning to look like a terrain, but still it's pretty static and we're not able to actually traverse through it, which is what we really want to do. So let's see how we can do that. How do we position the camera? It's pretty simple. The best way of looking at it is for every instance you rotate, translate, and scale the entire scene so that it corresponds to how you are moving about. The first step is to rotate, translate, and scale the scene so that your camera is at the corner of the terrain. It's not a must, but that's what I do in this project. You then add the input handlers, your mouse listeners and your keyboard listeners, So, for example, the mouse listener rotates the scene with respect to your mouse movements, and your keyboard listener translates the scene with respect to your keys pressed. We shall see how these actually figure in our code. Again, it's the same code as before, with just the handlers and the rotations and translations and scalings added. The first thing you'll notice are a couple of variables right here. Um, an interesting thing is camera scale, that basically determines how fast you want to move. So the bigger camera scale is, the faster you will move, because that's the factor by which you're going to translate the scene when you press keys. The functions that actually do something in this code are the keyboard handler, which is right here. And for example, if you press the W key, you change the rotation angles for the X and Y axis and the positions of the X and Z and Y coordinates, and you multiply them by the camera scale. Now you notice we're also doing something to a variable called bounce, and all bounce does is when you're moving through the scene, it kind of makes you bob up and down, which gives it a slightly more natural feel. Similarly, we have the mouse movement, and depending on the current position of the mouse and the last position, we calculate the difference, and accordingly we change the X rotation angle and the Y rotation angle. In both cases, we finally call update. Update redraws the scene, but before drawing that, it calls this function called camera, and this camera is what basically rotates the scene across the x-axis and the y-axis. And as you see here, apart from this, the only additions are in the draw scene method, where you call the camera function and you translate according to the new x, y, and z positions. So let's see how it looks now that we have some control over our scene. Alright, there you go. As you can see, we're now right in the middle of our terrain, and by moving my mouse and the keyboard, I can move around the scene. Now it's a little slow because I haven't really optimized it, but this is pretty much the basic gist of how it's supposed to look. And if you see me walking on this straight patch here, you'll notice that the camera is bobbing up and down, and this is because of the bounce factor that we added. Alright, now as a final thing to this project, let's see if we can add a character to this. Adding a character turns out to be really simple. Of course, the actual code to make a character is not really within the scope of this presentation, but if you have a built code for a human model or whatever it is, even if it's a box or a cube, you just place the character code in the camera function of our program, of our code. Just make sure that it is placed before the translations but after the rotations of the scene. What this ensures is that your character moves with the camera, but when you look up and down the y-axis, up and down the x-axis, I'm sorry, you do not move your character, because that will look really unreal and you don't want that to happen. Let's just try to place a small cube as a character and see what happens. Again, in this file, nothing much has changed. It's pretty much the same thing, except for one addition in the camera function, and that's right here. As you can see, just after the y rotation but before the x rotation, we draw a solid cube of 0.5 sides. And let's see, just by adding this, how we get the character of our cube on screen. And there you go, we have the character of our cube. And as you move around, the cube moves along with you. But at the same time, if you look left and right, the cube moves along with the camera. If you go front and back, the cube moves with the camera. But if you look down or up, the cube moves along with the scene and not with the camera, which makes it look like a third person. So there we go. We created a terrain and we added some texture to it. Then we added some mouse and keyboard controls so we could traverse the terrain. And finally, we added a character to it, which sort of gives it a third-person appearance. Of course, the possibilities are endless, and you could add whatever character you want, models. Just place the code in the camera part of the function.